The NASA ISRO Synthetic Aperture Radar or NISAR satellite is an Earth-observing satellite, a joint mission of NASA and ISRO with the goal to observe and measure Earth's changing ecosystems, dynamic surfaces, and ice masses, and to provide information about biomass, sea level rise, groundwater and natural hazards such as earthquakes, volcanoes, tsunamis and landslides. On September 30, 2014, at the International Astronautical Congress, NASA Administrator Charles Bolden and K. Radhakrishnan, Chairman of ISRO, signed a partnership agreement to launch a joint NASA-ISRO Earth-observing satellite mission. NISAR will be the first satellite mission to use two different radar frequencies, L-band and S-band, to measure changes in our planet's surface less than a centimeter across. This allows the mission to observe a wide range of changes, from the flow rates of glaciers and ice sheets to the dynamics of earthquakes and volcanoes. The mission life is 3 years and may be extended up to 5 years. NISAR uses a sophisticated information processing technique known as synthetic aperture radar to produce extremely high-resolution images. Radar penetrates clouds and darkness, enabling NISAR to collect data day and night in any weather. The instrument's width of the strip for data collection along the length of the orbit track is greater than 240 kilometers, which allows it to image the entire Earth in 12 days. It will send data in every 6 to 12 days. Under the partnership agreement, NASA is providing the mission's 24-centimeter wavelength L-band synthetic aperture radar, a high-rate communication subsystem, 12-meter diameter deployable mesh antenna reflector and 9-meter deployable boom, GPS receivers, a solid-state recorder and payload data subsystem. ISRO is providing the spacecraft bus, the 10-centimeter wavelength S-band synthetic aperture radar, the launch vehicle and associated launch services. The NISAR observatory's most prominent feature is the large 12-meter stationary antenna reflector mounted on a 9-meter boom. The reflector is made of a gold-plated wire mesh that focuses the radar signals emitted and received by the upward-facing feed on the instrument structure. During the transmit phase, a radar signal is sent up to the reflector, which focuses and bounces it down to Earth at an angle, illuminating a 242-kilometer swath. Radar signals bouncing upward off the ground hit the reflector and are focused back onto the radar for processing. Over the course of multiple orbits, the radar images will allow users to track changes in croplands and hazard sites, as well as to monitor ongoing crises such as volcanic eruptions. The images will be detailed enough to show local changes and broad enough to measure regional trends. As the mission continues for years, the data will allow for better understanding of the causes and consequences of land surface changes, increasing our ability to manage resources and prepare for and cope with global change. On March 4, 2021, the ISRO sent the S-band radar to Jet Propulsion Laboratory, California for integration with NASA's L-band radar. Once the integration and final assembly is over, the NISAR is expected to be launched around the end of 2022 or early 2023 from Sriharikota, India. The benefits of NISAR mission will be explained in the next video. Stay tuned. Thank you.